Hello, Internet. One of the things that I recently found on Twitter was I was following some Docker engineers, and they were talking about how they were adding Kubernetes support to Docker. So specifically, they're adding Kubernetes support to Docker in Windows and Docker on Mac. And so I have Windows, so I figured let's try this out. It's available in the Docker for Windows Edge or Docker for Mac Edge builds. So if you're just running the stable release, you're not going to see these options. But if you go and download their Edge versions, it might break some things because it's a dev Edge version, but you'll get this Kubernetes option. And so typically when you're running Kubernetes, you're going to be running a Minikube instance, at least for local development, which is going to be just sort of a virtual Kubernetes instance. This is a little bit more than that. It's not Minikube. It's actually going to be a single node Kubernetes cluster running locally on your machine. And so to kind of, I guess it says that here. But anyway, the point of Kubernetes, if you're not familiar with it, is it's sort of a system administrator as a service. I think that's how Kelsey Hightower talks about it, and he's one of the main advocates for that. So Kubernetes kind of allows you to automatically recover crashed applications. So if your application crashes, it will automatically start it somewhere else. It will handle like load balancing. So if a service gets under a lot of load, either just normally, say, I don't know, Black Friday in your retail store or something else, if that load gets really high, it can create new instances of your web container and actually handle that load organically. It will just do it for you. But generally, we're just going to be looking at how to use this to kind of just host some basic stuff. We could just use Docker. There's no reason we couldn't. But we might as well explore Kubernetes and see what it has to offer. So what we're going to be doing is just hello Kubernetes. I have a completely empty folder here. There's nothing there. And I figured I've been playing with Visual Studio Code a lot on my Mac, trying to get like Java working. I kind of moved away from IntelliJ to Visual Studio Code just to kind of see what that was like. And so I figured we'd try bare bones. We're going to set everything up from the console. So this should work on Mac, Linux, or Windows. It should be the same, I think. But basically, this is how you set up a project without Visual Studio. And then we're going to get that running in Kubernetes, hopefully. I haven't actually tested this cluster at all. I literally just set it up like an hour ago. So we're gonna see what happens. So I've been poking around just a little bit. And really, the only thing I've run so far is .NET new and help. The -help commands are really, really helpful for pretty much everything. Almost every package you're going to use is going to support them. This is just a PowerShell window, and we're just using .NET new in order to see what we can create. Specifically, I want a WebAPI project, which is just going to give us a way to return JSON or some sort of web content back. But it's not necessarily going to render a page for us. So this is what we're looking for right here. And so what I need to do is just .NET, ooh, that wasn't right, new, and we want web API. And so this is going to automatically create our project here. And if you do this in Visual Studio, this should be exactly what you would get there. So you'll see we have our CS project, all of that normal fun stuff. And then we can just run .NET build. And so this is just a normal project. It should just build. Let me know in the comments if the text is too big, too small, whatever. It always is kind of a struggle to get that balance right. But anyway, you can see our build worked correctly. We actually have a built app. And if I do .NET run, we'll be able to run this basic application. It should pop up shortly. So at localhost 5000, we've got something that is hosting this values controller. So at API/values, we should be able to call a get. So if I open Postman, I can just do that and do API. What did we call it? There we go, API/values. And we'll actually get value 1 and value 2 out, which is great. It means things are actually working. Now, we want to first create a Docker image. We need a Docker image because that is actually what Kubernetes is going to deploy. And then we need to be able to push that out to our new instance. So we need two things. First, we need a Docker file, which I'm actually going to just copy this from an existing .NET project. So this is from a project called the Text Content Service. And so we just want to take, oops, that's not right. Hello Kubernetes .csproj and copy that over there. Right? Yeah. And then I've never tried this before, so we're going to see if this works. I'm going to set the working directory to our source directory. Like so. So what this is doing is creating a Docker image. I should kind of walk through that. Wants to install Docker. We probably want to do that. And we'll just wait for that. But what this is doing is creating actually, I think, 4 Docker images. This one is going to build. So this is actually what's building our project. It's using this image, which is provided by Microsoft, which includes a lot of the required dependencies for an ASP.NET Core project. And then we are setting our working directory, which if you're in a terminal, that's just the current directory you're currently looking at in your terminal. And then we're just going to copy over some files to this new directory. So we're copying over our solution, which I don't know if we created, and we're copying over our Hello Kubernetes CS project. Then we're running .NET Restore, restoring all of that, copying over our local contents over to that directory, and then doing a .NET build. And so that should create our app. Then we're taking our app and publishing it, and then we're running it, I believe. Yeah, we'll see. I don't know if this is going to work, but we're going to find out. So I need to stop this. There we go. And so the cool thing, let's save that. I think nope, didn't get everything. Hello, Kubernetes. Yeah. So theoretically, that's everything that needs to be changed. I could be wrong. I've never actually just tried importing a Docker file like this for these kind of projects. So who knows if it's going to work. But I don't really have an easy way to build the Docker image to do all the stuff that I need to do. So we're just going to try this. And if it doesn't work, then I'll make something else up. So what we need to do is actually build this Docker image, which I'm going to reload Visual Studio so that that Docker plugin comes up. We're going to get rid of those two. And now we have this Docker image. I should be able to build it. And we're going to just call the image the end result Hello Kubernetes, and then we're going to tag it with the latest. So effectively we're saying this is the latest build for Hello Kubernetes. And so it's going to do all of this fun stuff in this new terminal down here. Yeah, that all fits. All right. And so this might take a bit. It's got to download all the dependencies and actually build your entire project. But once that's done, we're going to have an image that we can actually deploy in Docker. And so I guess the next logical step is to actually get that running in Docker. And then once we have that running in Docker, we can abstract it one level further and actually put it in Kubernetes. So effectively, we had an app running locally, which means it worked on our local machine, but that assumed that all of our configuration was correct. What Docker is doing is actually saying, we have a specific build set up. We have a complete network and all of that set up for you already, and it's under these images. So based on that, we need to copy these files over there and run this app. And so the advantage of that is you always get a consistent environment. So your environment is always configured the same, no matter where you put it, because it's always just that environment. And so then taking that one level further with Kubernetes, you get the ability to say, I actually want 6 of these, and I want you to send all the requests to this one unless that one gets overloaded, and then send them here. Copy failed, no files were specified. We don't have a solution. I don't know if we need this solution. Let's just copy that out and rerun this. Yeah. Specify a project or solution. Let's see, our working directory is source. We copied it over there. So let's copy it to our source directory. Actually, let's copy it there. Set a working directory to that. And now if I run this, nope. Doesn't contain a solution or project file. So the way this works is copy is going to take a local file. So it's taking hello Kubernetes, the first argument here is pointing to my local thing. It's saying take this hello Kubernetes CS project and put it in this directory. So I'm actually copying it into that image that I was talking about and putting it at, in this case, the root directory. But I think, can I put that at source? Yeah, okay, good. That makes sense. So now you can see it's actually running all those same build commands. It's doing a little bit more. It's restoring all those NuGet stuff. But it's actually building and running through and doing all of this stuff. So hopefully, unless we get an error, we should get a success. So if I do Docker images down here, we're going to get a bunch of things because I have a bunch of images, but one of these should be hello Kubernetes. And you can see we have hello Kubernetes here, and it was created 6 seconds ago, which is good. And it's the latest version. It's tagged with the latest. And so what I want to do is Docker run. And that's not how you do that because I need arguments. So let's figure out what those are. I'm just going to run the help command, figure out what I'm doing. And so what we're actually going to need to do is do Docker run. We're going to need to expose a port, 8080, I believe. Actually, we were doing 5000 before, right? We'll see here. I may get this wrong. So let's try that. We'll expose port 5000, and then we want to run hello Kubernetes, and we want to run the latest version. So the way this is working, Docker run is going to actually start an instance and get that running. We're exposing a port, so we're saying take this port from this running image and put it on the local host 5000. If you don't do that, I'm not going to be able to reach it because the port isn't exposed. And then finally, we need to give it the image name. I think this is everything. No. We got an error, was not found. This is not an issue with the Docker run command I just entered. This is an issue with the entire Docker image. That's unfortunate because I don't know what to do about that. So we put our hello Kubernetes there, moved everything over. So part of the problem here is I'm still learning Docker, and I don't think I like this. I think I want to do that. So let's try rebuilding this image and see what happens. Hopefully it doesn't take too long. Docker is going to save all of our images and reuse them. So the way this works is each of these commands creates a separate, I don't know what they're called, a secondary image. And those secondary images are kind of saved in steps. And so after all of this, we will get an image, and we can just, or not, after each of these, we'll get a sub image, I think. And then we can reuse those. So let's see if that helped. I'm like 50% sure that would have helped, and nope. All right, let me go and figure out what's going on. I'm missing something. Clearly I'm missing hello kubernetes.dependencies.json, but I don't know what that is or how to get it or anything. So let me go and actually do a little bit more research, figure out what's going on, and then we'll pick this back up. So one sec. All right, that took longer than expected. I'm glad my camera is over my clock, so you guys can't see exactly how long that took. But it shouldn't have taken that long. So did two things. One, I completely rewrote the Docker file. I actually took it from the template project on Microsoft's Docker GitHub. The problem is that wasn't exactly correct. It was for .NET Core 1, and everything for .NET Core 1 got broke when .NET Core 2 came out. So you need different images. So we have those different images. And then I got frustrated and downgraded the project from version 2.0.3 to 2.0.0. And that was just because I was getting all those same errors, which probably I could have worked around in a different way. But this solves it. And for now, that's fine. This wasn't really supposed to get too deep into that. But this is sort of the image we're having. So I'm going to kind of walk through this and kind of let you guys see how it is. This is actually a Postman request to the image. It's actually hitting that container, so we're good there. Everything's actually working. I just need to actually go and add Kubernetes support now. So what this is doing is we have this initial image. So this one is based off of the ASP.NET Core build image. And so it's going to have everything you need for compiling ASP.NET Core, which is going to include .NET Core and a few other things. And then we're naming that image as the build environment. And that comes into play down here at that other highlighted bit. Then we're going to copy over our CS project file. So one of the things to keep in mind is Docker is linear, which I guess most code is, but that matters a lot in this case, because by copying over just the CS project file, we don't necessarily have to refresh all of our dependencies every single time we change any code. What this does, these two lines are going to copy over our project and then restore all the dependencies. And the important thing of doing this first is we don't want to have to restore all of our dependencies and re-download them every single time we change any code. And so by putting these first, we can save the output from this line and then use it down here when we copy over everything so that we don't need to redo that. So down here, that's exactly what we're doing. We're taking the entire directory and copying it over into the image and then doing a publish, which is going to actually take all those dependencies and package them up. And in this case, we're creating a debug output. There's prod something. There's another package that you can use to actually deploy a production package. Don't really care about that because we're not deploying to prod. Then down here, we actually need to run our app. So we don't need all the build dependencies. We don't need that stuff. So this is going to be a little bit of a lighter weight image. It's just going to have everything you need to actually run thing. It's going to have the .NET runtime. So this is what you would have just out on your server. And then we're going to take our app directory and take the output from this build that we created. And then we are going to run that. And this hello kubernetes.dll is going to match the output here. Right there. That is probably super small on the recording, but it's just hello kubernetes.dll in my bin directory. And so that gets us running. And then you just have to do the same commands that I was doing. So we were just running a build for our Docker file and doing all that. That command is the exact same. The other one, we're actually publishing the port on port 80. So I needed to change that from 5000 to 80. And then once we get that, why did that throw an error? Apparently I can only run that once. Error response from daemon. Driver failed programming external connectivity on endpoint Jolly. I don't know what that means. Let's try that again. Nope. Oh. Why are those still running? That's odd. So normally with Docker, when you would stop an image, it would stop and they would go away. That isn't happening here. So Docker PS is going to list all of the currently running currently running images. So we have Docker, oops, that's not right. Docker images, which is going to actually display all of the images that we have made that are in our local repository. Docker PS is actually the running instances. So theoretically, you would expect if you just run this on a clean install, there shouldn't be anything here. We have two things here. We have one running on port 5000 and one on port 80. We don't want either of those. So let's stop them. We can just use the names on the right side there. You aren't going to be able to see them because my camera is going to cover them up. But if I can't show you that. But if I just stay stop and then use the name, no such container. What? Well, this is just weird. So, let's actually try just copying that. What? Am I missing something? I feel like I have to be missing something. You can't quite see those yet. Now you can. So this is the name that I was talking about. Is that extra little bit screwing me up? Okay, can't resize that. That's fun. Stop. The relaxed bows. There we go. So maybe that was the problem? Yeah. So there's a second L, apparently. Interesting. It was wrapping that one L. And so now we stop both of those. If I do Docker PS again, we have nothing running. And so now this should start without any issues. Cool. So there's some unfortunately quick debugging, but whatever. We get there, which means we can now get these values back. Cool. Sure, this is going to run a little bit long, but that's fine. Let's deploy this out to Kubernetes. So Kubernetes, you manage that with kubectl, the kube controller. And so here's everything you can do with that. There's a bunch of the stuff. What we're interested in is create. So kubectl create. Actually, first, we're just going to get the current pods in my instance. There's nothing there. And we're also going to kubectl config. I don't remember the command for this. What's the current context? So kubectl config current context. And so this is useful because I actually have two contexts. If I do kubectl config get contexts, you'll see there's two here. One of them is for my Minikube instance, and one of them is for my Docker for desktop instance. We're exploring the Docker for desktop stuff, and so we should expect that star there, and that's what the current context is going to say, where it says we're using Docker for desktop. So you can switch that pretty easily just using kubectl config. There's a set somewhere. or not set. Set is different. You want use context. So if I want to say switch to Minikube, use context to Minikube. And there we go. We switched. And if I want to go back, Docker, for desktop. And so that's just a really easy way to switch. If you're running a production environment and stuff, you probably are going to have multiple ways to get to things. And so, or you're going to have multiple contexts. You're going to have prod or whatever. Maybe you separate your apps into separate contexts. However you do it, that's how you switch. Anyway, that's totally irrelevant because that's really just showing we have multiple environments that we can manage. What we need to do is do a create and get some help here. And so create is going to take an image, or not really an image, it's going to take a definition of what your script is going to do and actually deploy that. So let's create a deploy.yaml file. No charts found. I have Helm installed, so that's why you're seeing that. But let's do a snippet and create a deployment. This is huge. We don't really care too much about this. And a lot of this can probably go away. But this is just a really basic, I ignore all the templating stuff, but this is a fairly basic template file for a deployment. And so we don't care about a lot of this. For example, this is just hello Kubernetes. Let's actually go lowercase. Kubernetes, there we go. And we'll just replace some of those things. Container name, hello Kubernetes. We need an image name, which is going to be equal to whatever we call our Docker image, which is hello Kubernetes without a space or without a dash. I'm being very consistent. Kubernetes latest. Image pull, if not present. So this is going to specify if your image should be pulled. So your Docker image, should that be pulled from your remote source? Or if it's stored in the cache, should that cached file just be used? So if this is going to say if that cached image is not there, then go and retrieve it. Otherwise, just use the cached version, which in this specific case isn't the greatest idea because we just used latest. And the problem with that is we're always replacing that image with the new one, which means we don't necessarily know if anything happened. You probably want this in like a prod instance because you don't necessarily want to just pull, if somebody recreates a Docker image that's equal to your prod instance, you don't want to just pull that into prod. But in this case, it doesn't so much matter. We're gonna ignore that. Container port, we'll just use 80. Liveliness and readiness probes are used specifically to see if your container is alive and if it's ready. So if a container is ready, traffic will get sent to it. If a container is not ready, no traffic will get routed to it. So your container has to say it's ready before anything will be able to reach it. And then liveliness, if it reports unwell, in this case, so anything besides a 200, Kubernetes is going to kill that pod and create a new one somewhere else. In this case, it would create it in the same place. But if you were to say make something unhealthy, maybe it can't connect to a database that is critical, or it's having some other issue or gets into some weird state, you may want to get rid of those. We're gonna get rid of those resources. I don't think we need those replicas. Let's just create one. Chart name. Do we need a label? I'm gonna delete these because I don't know what they do. How's that for smart moves? All right. I think we're good. I may have screwed a few things up because it's been a while since I've had to just make one of these. We have a template that I use. But just going from scratch, this is just a snippet that is part of a Visual Studio extension. Which extension? This extension, Kubernetes support by iPadrezas. It just adds a bunch of snippets. This was the one we used. I don't know why they just get a type and I didn't. But oh well. I guess that's the way it is. Maybe I'm doing snippets wrong in Visual Studio Code. I don't really know what I'm doing. So theoretically, if we got this right, our Docker image should have its repository for the images it uses equal to what we have locally. What that means is Kubernetes needs to know where to take your images from. If you're at some like a corporation or some business, you probably have some server somewhere that stores all of your builds. In that case, you would point your Kubernetes instance out to that server, and it would just pull them from there. In this case, we want to pull them from our local host. So I'm assuming, I have nothing to back this up, but I'm assuming that Docker automatically configured it so that it would just pull from my local Docker because it's made by Docker. If that's wrong, we're going to have to set that up. So anyway, here's hello Kubernetes. If this works, when I do kubectl get pods, we should have one instance of hello Kubernetes running out in that instance. So to do this, we do kubectl create, and then we need to do -f to deploy a YAML. And we created our deployment, which I'm hoping worked. It's out there. It's not ready, which I don't know if that's because I screwed something up or not. Probably screwed something up because it's been 15 seconds and it hasn't come up yet. So git logs. We don't have code completion. That's unfortunate. So we can just get into the logs for our pod here. The path does not exist. Oh, what am I doing? Not git logs. kubectl logs is what you use to do logs. -f is going to be to follow those logs. Okay, so it started it, and then it shut it down. Why did that happen? So our app did start up. Here it is. It started, and then something caused it to shut down. And I don't know what triggered that. Well, let's see here. It could have been those readiness and liveliness probes. Because I don't know if our application is configured to actually handle those correctly. So let me just run this instance in Docker. We need to kill it. Docker stop stupefied Euler. Cool. It's really weird that those don't get automatically killed, but anywho, we can start that. Now if I just go here, we get a 404, which means our liveliness checks, our readiness checks, are going to just get 404s constantly. So we actually need to update both of these and actually point them at something that will work. And the easiest way I can think of is to point them right at this. It doesn't make the most sense, but for this, we already have it. And it saves us having to actually create anything. So if I send them to API/values, instead of that 404 in endpoint, we should be able to, let me kill that currently running Docker instance. Once we kill this, we should be able to deploy this new version. And my hope is that it will automatically update that, and then we'll be able to actually see what's going on. So I think there's an apply. Yes, okay. So there's a slight difference between apply and create. Apply will actually overlay whatever your changes were on top of the currently existing one. It's sort of like an in-place update. Whereas create, you can't create something if it already exists. So if I tried to rerun that create command we ran, it should throw an error because we already created a hello Kubernetes instance. That already exists. So we can't just go and create another one. What we need to do is apply this on top of it. And that's just sort of a safety feature. And there we go. And so if I get these pods, we have a new one that just started, it looks like. And so let's grab the logs for that. And we have our application started. So, and it's ready. Cool. Which means we have a running instance out in the middle of Kubernetes. Problem is, I don't think we can get to it. We didn't create an ingress, which is how you actually connect to these things. By default, everything running in your Kubernetes cluster can only be accessed by other things running in your Kubernetes cluster. Unless you add an ingress, which actually handles that traffic, you're not going to be able to actually access it. So, what's the easiest way? Git, let's see if it created one. Nope, there's no ingresses. I wasn't really planning on doing this, but let's see if there's one for an ingress. There is, cool. So, let's create an ingress. This is going to look fairly similar. Going to delete that. Our release. I'm less familiar with ingresses in Kubernetes, so this is going to be less nice. Give me 1 second. I'm going to go pull up the actual documentation instead of just basing it off of this, because I think there's more here than we need. All right, so this is Kubernetes basic documentation. Let me make this a bit bigger. That seems big enough. So I think we should just be able to grab this one. This should be all we need. And so if I bring this into Visual Studio Code, we can expose port 80 for our hello Kubernetes instance. And there we go. So this is going to create an ingress for hello Kubernetes and expose port 80 of that service out to the world. So we just need to do another kubectl create ingress.yaml. And we should now have an ingress created. So if I do kubectl get ingress, it exists. Now, I don't know how these work locally because I don't really use them locally. But theoretically, port 80 now should be exposed. I don't think it works like this, but we're gonna, yeah. One last thing. I want to try HTTPS. No. Okay, good. So that doesn't work. Git. I'm trying to figure out how to make it show me that. Because so the problem I'm having is it's not exposing it locally. And that's what I need. And I don't know how to do that because I'm not super familiar with Kubernetes ingresses. Because, yeah, just haven't needed to set them up too much. So, I guess more digging is required. But this is at least a basic ingress. We can at least build off of this. I think I'm just missing one or two things. So, one sec. Okay, I think I found a solution. We're not going to create an ingress because I think that's just overkill. It looks like there's an expose command that we can just take advantage of. So here's one of the examples from the help docs. And they're just exposing, say, an Nginx server. And they're taking port 80 and exposing it on port 8000. So this is actually going to be similar to what we did in Docker. So, except I'm going to expose it on, let's do 8080. Make sure that works. So we should have hello Kubernetes instead of Nginx, because we don't have an Nginx server. This should have exposed our hello Kubernetes deployment on port 8080. So if I go there and call this, it still doesn't work. Why not? Git pods. What'd I do wrong? Still running. What if we describe our deployment? So this is just mostly trying to figure out what's going on. So if you do a describe on a deployment or a pod or anything in Kubernetes, it's going to give you a series of events that have happened on that. So in this case, we're scaling up 2 instances, and then this one is scaling down that second one. But I am not seeing anything getting exposed. Port 80. Huh. Error from services. Oh, is that what was happening? kubectl git. I probably didn't have that. Let's see if that works. Cluster IP. That I don't think this is gonna work, but let's try this anyway. That's usually a good, you know, line of thought, right? Okay, good. I don't know what the cluster IP. Huh. I don't really know what that means. Oh well. I'm kind of stuck though. I was expecting expose to just expose the port to localhost. But that didn't happen. Like, if I go to 8080 again, we get nothing back, which is confusing to me. I was expecting that to just work. Huh. I must have missed something. Let's see here. kubectl expose help. Looks up a deployment and uses the selector for that resource as the selector for a new service on the specified port. I finally figured it out. Took a little bit of work, but first deleted the old service that we created. So when you run expose, that creates a service. Think of a service like something you're giving out to people. That's not a great description. But then once you've deleted that service, after you do that, you re-expose Kubernetes, and you'd use node port to create that. So instead of giving the explicit ports, I just gave it type equal to a node port, and that created another service, which I can't go down anymore. But if you do get services after that, we'll have a new one created. You can see this one's only about 2 minutes old. And so we're taking port 80 from our current node and exposing it on port 31,299. And so if you plug that into Postgres, or into Postman, not Postgres, different things, it actually works. And so we can actually talk to that now. And just to kind of really prove it, let's scale. Let's see if I can remember this off the top of my head. Replicas equals to 0. Our deployment, hello Kubernetes. So this is going to scale down the deployment that we created, this thing, which said that we needed a 1 copy of this running. I just told it to have 0. So if I go here, we don't have anything running anymore. So if I run this, we don't get a response because nothing exists. But the cool thing is I can scale that back up. And for fun, let's say I want 8 of them. This is going to create 8 copies of that service and expose them all. And so when I hit this endpoint, it's the ingress we created is going to automatically determine which of those to send my traffic to. So this is actually not, even though the IP and everything is the same, we're not necessarily hitting the exact same container every single time. But that is getting a .NET service stood up and deployed out to Kubernetes and using Docker and everything else. I don't know, it took a little bit longer than I wanted, but all in all, it only took like 1 hour and 30 minutes total to get all of this with all the research and everything, which isn't bad. Kubernetes is still fairly new. I think it's only a few years old, and the tooling isn't quite there yet. And with every new layer of abstraction they add, it just gets, there's more setup required. So it's not the easiest thing to get stood up on, but once you have taken those steps, it becomes a lot easier. So compared to like standing up, just deploying something to a server, that initial deployment to the server is going to be way easier. You can just drop your binary on there and you're good. Here you have to kind of set things up. You have to build your Docker image, set all that stuff up. But once you get all that done, it's almost the same amount of work. And if you run into something where you need to like copy your server or something, or your machine breaks or anything like that, this is resilient to that, whereas the manual solution isn't necessarily. So it gives you some advantages, but it can be a bit of a hassle, especially if you're new to this kind of stuff. I've only been working with it for like a year now, so we'll see. But yeah, I'd love to hear what you guys think of this. There's definitely a lot of unexplored space that we could go through here. So yeah, if you guys want to see more of this, check it out. I have a video on using Helm with Minikube, so you can actually deploy pre-built containers. So you don't need to go through all of this. It will actually create a container for you and actually pull in all the dependencies, stand them all up, and get everything up and running for you. So if you want to use that, I'll link the video description after this outro, and you guys can go and catch up on that. Otherwise, that's pretty much it. If there's suggestions you guys have or anything, let me know in the comments, and I'd love to hear them. This one has been on my wall. I have a wall of Post-it notes. That's not really helpful. But I have a wall of Post-it notes that I use to kind of keep track of all of your guys' suggestions and ideas of things that I want to do. This one has been on there for a pretty long time. So if you guys have other suggestions, I can create a Post-it note and throw that up there. And hopefully we'll get to it when we get to it. But that's it for this video. So until next time, see you, Internet.